So today we're going to make this component. We'll make this component the HRN 232. Where you have the data sheet here. So you know it's a true whole component 16p. We're going to be using this. So we want to make the pattern for the component. Here we go. This is a zip. (16), not 24. This is 24. 16. Then that is what we're looking for. So we are not going to do it in the basic way. We are going to do it in the faster way. The faster way of doing it. We're going to do it in the 3D model. So this is what I'm talking about here. We're going to name it. Put in the name DIP16. The reference of the little view. The manufacturer in this. So normally we would have done this lines, which is a basic way to is 16p component. The line spacing here is from here to here. E, that's this here. So that's E here is we use the maximum 8.25. So we put E here to be 8.25. Then the part spacing, that's the spacing between two parts. Let me try that for you. So between these two parts, what's this? Yeah. And line spacing is the spacing between two lines. So you get it 8.25. Then we'll go check this. This is between lines. That's pitch to pitch. That's a pitch. Pitch to pitch. E is 2.5 for basic BSc. It's in millimeters. Don't worry about BSc. So that's it here. So if you choose to modify it, you could like this pad hole is kind of too big, so you could basically just copy all of these part properties and check this through hole already. Is an ellipse. We use an ellipse template, pretty much onto the template like that. The width we use 1.7. Why do we use the 1.7? Because over here we use this B1 here. B1 here is the maximum here. Is giving us a 1.7. That's in here. So that we use 1.7 on both sides. 1.7, 1.7. So if we choose, if we want to adjust, yeah. So if you want to adjust the whole width, you check all. If you do it, right click, part properties. Anything we put here, you can make it to 1.1. You can see it reduces. You can make it 1.4. You see it further reduces. Or you can still make it we can make it 0.5. Let's see, it's going to be very small. Yeah, we have it. So already we're done, but you could see in the 3D model there is no component, like there's no 3D component. I know there are different ways of doing this here, but I'm going to show you the easiest way. Normally you could download the step file, yeah, but that's pretty much a long process for me. So you could finish this up by simply putting this up here. You could choose to use the dimensions too. E1 here is 7.11. So it's not all that important. E1 7.11. So I'm going to take my tool here. I'm going to mark from here to here and draw it out. So if I make adjustments to the box, okay, I made a mistake somewhere. Control Z. Okay, we do this again. We choose the vertical. We want to measure from this line here to this line over here. I want to make it 7.1. So we could adjust it. Yeah. Cool. 7.11 is cool. Then length, the D here, go for the maximum value 19.68. So come over here. We could take this out now. Delete. You click on it, and you click delete. So we can measure using this horizontal. Touch it here. We draw it to the other end. Touch it, then take it out. So what you're looking for is 19.68. So you could either adjust it. We make an adjustment like this. Or why stressing ourselves, we could just right click on this properties and just put it in here 19.68 or 7.11. That's all. You draw, you try to centralize. Yeah, you got it. Delete. Then you could also indicate your pin number 1 for conversion reasons. So this is just one way, which is a very basic way of doing it, right? But you won't get a 3D model for it. This is what you just get, a true whole component. So, like I would say, the fastest way to do this. Let's take this out. We're going to delete all this. We're going to get here. You can lock it, or you can unlock it. So we're going to use IPC 7351. It's a standard. I will come to IPC generator. So over here, you can generate anything you want to generate. This is surface mount. We're looking for the true hole component first. Dual inline package DIP. So over here, we can adjust the package. Pin count, we need 16, right? The maximum for E, because E is pitch, is the line distance of both lines, but that's different size of the IC. Oh, and already that's 8.25. The E1, we got its maximum here is 11.1. The E here, that's the pitch from pitch to pitch. E should be small letter E. Yeah, it's 2.54 already is there. Then pretty much everything we need. So what you do is you recalculate. Then if you choose to go through all these, good. But we want us to sleep here. You get part shape, you can adjust part shape. If you need it square, if you need it round, if you need your first part to be square, you could adjust it here. And all 3D design. That's all you could recalculate. And okay, so that's it here. We have it here already. So you can see it's generated it automatically, easy way, and we could confirm the dimensions. The vertical, take it from the middle, take it to the end. Oh yeah, didn't give us. We'll have to do that. This pitch to pitch, we got it right, and that's pretty much everything, you know. But over here we could check for the 3D model. Voila, there we are. Easy peasy, fancy squeezy. So here we are. We'll have that. Okay, so that's all for now. If you choose to do some more adjustments, you could just come over here. 8.25, yeah, E1. Yeah, so that's pretty much everything you need to know here. You could do that to other components in your library. If you need a DPAC, you could do it to DPAC. Use a DIP. Okay, let's try this with DPAC. Now we're going to get rid of this. Okay, this is locked, so we could unlock it. Unlock selected. Delete. Now pay attention to this. Through the model, nothing. IPC, this generator. We're looking for a DPAC. Okay, we have a DPAC here. So we have a component such like this. Majorly DPAC components are kind of transistor-like components. Okay, so we are using this is the DPAC. This is a component you're using. This is a 5-volt regulator 7805. So these are the different packages: T0220, T0220P. You see the ground of this is at the back. It's extended. The ground of this is kit. It's not extended. It doesn't show it's extended, but it's not conductive. So you can see this. These are surface mounts. These are true holes. So we're going to continue concentrate on this. So yeah, right there. Yeah, it's taking so much time. There we go. I'm kidding you right now. Okay, this is a deep arc drawing. So you're looking for the footprint for the pattern. Yeah, this is the pattern. So you're looking at 6.3 by 6.1. You come over here, pitch. We're actually wearing given a pitch. Pin count 3, pitch. Let me see. Yeah, pitch 4.5, 4.572. Let's bring that closer. 5.5, 4.572. We put that in here. 572. What else do we need? D1. Oh, this is going to be D1. Maximum for D1. D1 here is 5. D1 5.10 maximum 5.7. Yeah, that should be D2. Sorry, 5.10. D1 we take it out. Yeah, because the convention is not the same. So we'll look for D1. Which is D here. It's 6.20 maximum. Remember, we're taking the maximum values. The D is the full length of the case. Okay, what's it here? The full length of the case is H. That's it here. H. Come on. Come on. H is 10.1. That's it here. 10.1. 10.17. The B. Okay. Well, you pretty much get the points. I have to do all this. Okay. So we got this, and yeah, this is the points to treat the model. Let's see. Easy peasy. Journey's crazy. Okay. And if you wish to adjust the component on the pad, rotation, you have the pitch, the roll, and the yaw. So if I adjust the yaw, you see it shifts along the Z axis. That's the yaw. You could put that 180 or 150, or we could just leave it at 89. It's not properly placed. We could make it 90. Voila. I guess that's pretty much everything we need to know. Then don't forget to save up your work. I'm not going to save this. Yeah. Thank you.